All right, hello everybody. Let's do this. So we're on page S.52, and just to leave the cliffhanger from part 2, when we needed to calculate which triangle this was, it was the 60, 30, 90 triangle here. Because if this was 2, right, this had to have been 2, this had to have been 2 square root of 3, this would have been the triangle, because notice this is, I know this is 4, right? So if this is 2, 2 times 2a, this would be 2 times 2 is 4. So it would be this one that matched. And notice that the radical opposite of that 60 was 2 root 3. So this was the triangle that matched. And if you knew this was 60, then this whole rotation had to have been 300 degrees. Because if this is 60, 360 minus 360 minus 60 gave you 300. Okay? Alright, so, and this would have been the answer for this part here. Alright, so let's do this. If we wanted to see how to do the next couple of questions in this section, remember we're on page S.52. Alright, it's right over here, S.52. Here, let's go to question 4. So it's saying, what is the modulus of the complex number 2 minus 2i, right? So we could do this easy peasy. I just say z is equal to, z is equal to 2 minus 2i. And what do we want? We want to find the modulus of z. So I know you can do this, right? Also, it's telling you find the argument. It's telling you to write it in a complex number in polar form. And I'll get to what this means very soon. What I want you to do is try and do question 4 by yourself, right? If you did these questions here and you felt good with it, these two, go with it, all right? If you want to see the solution and see how it's done, here it is. So the modulus of this would be square root of 2 squared plus 2 squared, which is square root of 4 plus 4, which is square root of 8, but that's equal to the square root of 2 times the square root of 4. So that's equal to 2 root 2, right? This is 2, so it's 2 times root 2. So this is our modulus here. What is the argument of 2 minus 2i? Well, let's see. I need to, where is 2 minus 2i in the complex plane? I have 2. This is minus 2, so I know this is my point here, right? Now when I make my triangle, remember, argument of z is talking about the rotation from here all the way to here, to this point. And it's asking you how much rotation was made when you talk about the argument. So the way you need to figure this out is we need to use these triangles that we have. These are like the new triangles we looked at. So you have to see which triangle is made here and subtract it from 360, or try and find how much rotation is here. So finding this angle here is very important. So let's see, what kind of triangle was made? Okay, that was a bad triangle. So it's something like this, right? And if I know we have 2 minus 2i, I know the distance from here to here has to be 2, and the distance from here to here has to be 2. And notice that if I have the same legs of the triangle, then I know that I'm using this triangle, right? Because these two are the same values. And notice that this is just 2 root 2 here. So for sure, I'm using this 45, 45, 90 triangle. So I know that this angle has to be 45. If this angle is 45, then this whole entire rotation is 360 minus 45, which is 315. Okay, so I know that the argument of 2 minus 2i is equal to 315 degrees. Okay, now how can I write this complex number in a polar form? Well, we just kind of already did it. Here, remember, in a polar form, what's our formula? We need r times cosine of theta plus I sine theta, right? And now here we already have our r. The r is equal to the modulus of z, and we just calculated that. It's 2 root 2. And here, the cosine, our theta or our argument of the z, how much rotation was made, was 315 degrees. Okay, so coming back to this, we found that the modulus of z, was 2 root 2, and we found the argument, right? So we just plug it in. So this is going to be 2 root 2 times cosine of 315 degrees plus I sine of 315 degrees. And that's it. This is the polar form of this complex number, 2 minus 2i. Okie dokie. And now it says arguments can be measured in radians. Oh boy, do we remember what radians are? We're talking about pi radians, right? So pi is equal to how many degrees? It's equal to 180 degrees. So like if I want to talk about rotation, right? Well, this is 0 degrees. This is 90 degrees. This is 180 degrees. This is 270 degrees. But how do I show this in pi? Well, this is 0. Yeah, like 0 pi. This is how do I get 90? It's 180 divided by 2. So it's just pi over 2. And this has to be 80, right? So this is pi, and this is 3 pi over 2. And the question is, how can we get this? The arguments can be measured in radians. So express your answer in part C using radians. So here, how do I convert 315 degrees to some pi radians? And if you do the math, it should be, what is it? 7 pi over 4. And if you're thinking, oh boy, how on earth did I know what to do that? What you do is you take 315, right? And you're going to multiply it by, what are you going to multiply it by? Pi over 180. So then that's equal to 315 pi over 180. And if you find what is the greatest common factor of 315 and 180? Oh boy, let's see. If I divide it by 5, let's use a calculator. Let's see. What is the greatest common factor of this? I know it should be 7 pi over 4, but let's see. What's 315 divided by 5? Okay, so that's 63. So I know this is 63 pi over, I'm sorry if everything is very squished, but it's 63 pi. And what is 180 divided by 5? That should be 36, right? This is 36. And then can I keep going? What's the GCF? Oh, it's now it's 9. So here it's divide top and bottom by 9. 63 divided by 9 is 7 pi, and 36 divided by 9 is 4. So the GCF actually of 315 and 180, the GCF was 45. So yeah, my bad. It's early in the morning. I should have known that. But then this is it. So then the way we could just substitute this. Whoops, sorry. We could just take this and write it as. I am running out of space here. Let me write it over here. It could just be 2 root 2 cosine 7 pi over 4 plus I sine 7 pi over 4. Okay, and this will, let me zoom in a little bit, and this will be it. Okay, this is in radian form. Okay, we got to remember how to do this. All right. Let's go to the next part, letter E. If you didn't get a chance to do E, what I want you to do is try and do it. Why is this number, why is polar and rectangular forms of a complex number, why do they represent the same number? And that has to do with the check we did. How do I check that 2 root 2 times cosine 315 degrees plus I sine 315 degrees, why is this equal to that complex number we got? Why is it equal to 2 minus 2i? Okay, so what I want you to do is try and check it, and then we'll go back to the next video. I'll see you.